So after we have talked about kinematics, the GLB, Gerak Lurus Beraturan, and then we have reviewed about the vector. Now it's Unity time. We will try to apply the knowledge of Gerak Lurus Beraturan into Unity. Okay, so you may want to copy your last week's projects folder, and give it a new name. For example, like car test 2D, part 2, or test 2, and many others. In the Unity Hub, you can manually add projects in the project tab, like so, by using the add button. And then please browse to the Unity folder you want to add to this Unity Hub. Instead, I will use my last week's project. Here I have my project is the Hello Unity. I have opened it over here. So last week we already have moved our car, using a simple button, change bit here. If I enter some value here, then my car will move according to the value entered in this text box. Okay, so previously, actually you have created GLB simulation, although it is only on the x-axis. For this week, we will try to move our car on both axes, and also we will move our car into a specified target. We will also be using the Text Mesh Pro. We have done it already previously in the previous week. So let's dive in then. I will move my car over here. Let's say I will move it into the topmost position of my screen. Maybe over here. Or actually, if you want, you can move it anywhere you wish. And then let's add two input fields with a Text Mesh Pros version, and then also a Text Mesh Pros to label it. Let's label it destination X and destination Y. And then add a button, set destination. Let's add it for now. Let's see. I will focus to my canvas first. And then, okay, let's move this two UI elements outside of the canvas. Because we want to make room for destination X and destination Y. Okay, so as usual, right click on your canvas, then select the UI, and then I will add my Text Mesh Pro first, the text. Then I will move it over here. I think it's too big for me. I will resize it a little bit. I will reduce the font size. Maybe 24 will suffice. Okay, I think that's fine. And then let's change the text into destination X. I will move it further up. Then I will add my input field, again, Text Mesh Pro. I will move it over here. Okay, let's see. I have some unused room for my destination X label, so I will shrink it like this. So then I can make a room for my text box, or input field here. Okay, so leave it in destination X. Then rename your input field into something like destination X input. And then grab these two UI elements. Then just copy and paste. I will duplicate them instead by pressing Ctrl and D. Then I will move it further down below. Okay, let me readjust my label and the input field. And then I will change it into, this one is destination Y. And then this one, I will rename it to destination Y input. And then let's see. Okay, we have the set destination button. I must move my user interface upwards. Okay, maybe this will suffice. And then I will add my button. Yeah, again, right click, then select UI, and then I will use the button text mesh pro over here. I will move it over here, change the text to, let's say, okay, set destination. Set destination. Oh, the font is too big for me. I will reduce it maybe 18. Yeah, I think that's fine. And I will rename this button to set destination button. Set destination button. Yeah, okay. So my user interface is complete for now. Yeah, if you want to move it to center like this, then it's fine. Yeah. Let's see. Can I move it to center? Yeah, I will select both of my text labels and then I will align it center. Yeah, something like this. Yeah. Okay, so the next step, we will make the target. Yeah. Please download the target.png from the classroom. Yeah, and then create a new 2D sprite, name it target, put it in the position 0. Yeah, x equals to 0 and y equal to 0. Okay, let's say I will import my target PNG here. Yeah, just drag and drop. Oops, sorry. Okay, and then I will move this sprite. Yeah, I will create a game object based on this sprite. Yeah, I will just drag this target and drop it to the hierarchy. Then, okay, my position is already in x equals to 0, y equals to 0, and z equals to 0. Yeah, be careful about the z order. Yeah, please make sure that your target is positioned in the z equals to 0. And as well, please check your car. Yeah, your car's z position should be 0 as well. Okay, I think my target is positioned correctly. Yeah, in the 0.0. Yeah, x equals to 0 and y equals to 0. Yeah, we will use this target as the mark of our destination, yeah, or our target. Okay, so the next step, we will create a new C# script for the target game object. Yeah, let's create it. Go to your scripts folder and then right click, create C# script. Yeah, remember to name your C# script immediately. For example, target. Yeah, and then usually when I have created C# script, I will immediately attach it to a game object. Yeah, in this case, I will attach this target script into my target game object. Yeah, this to make sure that my target script will be run automatically when my game is run. Yeah. Okay, let's open the target script. Yeah, while waiting, my Visual Studio is being opened. Let's go back here. Yeah, so basically this script will allow us to actually move the position of the target game object, yeah, to the specified input. We have here, if you look at this script, Yeah, we have two public fields, which is the input X and input Y. Both are TMP input field. And then we have button here. Actually, we have a function that will be run when the button is clicked. Yeah, the set destination button is clicked. Yeah, here we will get the value from both input boxes, yeah, input fields, store it into a variable new X and new Y here. And then we will move the position of our game object, yeah, to the specified new X and new Y. Okay, let's do it. I think my Visual Studio is ready now. First, I will create a public TMP input field. Yeah, if somehow your Visual Studio does not suggest you this TMP underscore input field, yeah, then you may want to include TM Pro above. Yeah, so if your Visual Studio does not suggest TMP underscore something, yeah, you may want to type using TM Pro first. Yeah, only by then your Visual Studio will recognize any classes that is in the TM Pro namespace. Okay, so I will create my two input fields, input X as well as input Y. And then I will delete start and update. I don't need it for my target. Yeah, but instead I will create a public void set destination, set destination function or method. Yeah, here we will get the user input float x equals to float.parse from input x.text. Yeah, similar to y, let's create a float y equals to float.parse input y.text. Then we will move this game object's position to the new location. To move any game object's position, yeah, especially the game object that has the script attached to it, yeah, we can just call transform dot position equals to new factor 2 x and y. Okay, save your target.cs script. Then, yeah, make sure you have attached this target script to your target game object. Yeah, if you want to check, then just select your target game object, then look at your inspector. You must have the target script component over there. Don't run your game right now, yeah, because we have to specify two input boxes here, yeah, or two input fields, which they are currently none for now. What we have to do is just drag the respective input fields into the respective fields, yeah. So for the input X, I need to specify the destination X input as its value. So just drag destination X input from the hierarchy to the input X field, then drop it. Yeah, in the same way, please drag the destination Y input from the hierarchy to the input Y field over here. Yeah, until both of them are filled with the respective input fields, then you are able to test your project or your game. Yeah, just press play. Okay, now I will try to input some destination here. Let's say 5 for X and 3 for Y. Yeah, if I click the set destination button, nothing happens. Yeah, why? Yeah, remember you have to specify what function will be called when you click this button. Yeah. I haven't done it so let's do it for now. Yeah. Remember to add a function to the onClick event. Yeah, just select your button. Then at the inspector, please scroll down until you found the onClick list. Then click plus. And then let's drag this target game object over here until the no function drop-down box is active. And then select the script target and select the set destination function. Yeah, this will tell Unity that we want to run the set destination function from the target script, yeah, owned by the target game object when the set destination button is clicked. Okay, let's try it now. I will enter the destination X is 5, destination Y is, let's say, 2, and then I click the set destination button. Voila, yeah, the target game object moves to the 5x and y equals to 2. Yeah, if you want to check, then just select your target game object and check that your position is x in 5, yeah, y equals to 2, and z is 0. Yeah, so my destination set destination button is complete now. Okay, we have done this. Attach a script to the target game object and connect the input fields. Use the buttons on click section to run target set destination function. And then let's do the next part. Yeah, that is to move the car. Yeah, previously we have created the car script. Yeah, to move our car according to the speed input here. Yeah, we do it in the change speed function. Yeah, but now we want to edit the car script. Yeah, because this time we want the car to move to the target game object with a specified speed. Okay, so I think we can move this to user interface elements back into the canvas. Yeah, and I will move the change speed button over here. Yeah, if you want, you may want to add some label here, yeah, to specify what is the input expected in this input field. Yeah, or else you can also use the hint or the placeholder here. Yeah, so instead of the enter text, I will call it hint. I will change it to move speed. Or if you want, you can add another label, yeah, to specify that this input is for the move speed. Okay, so let's edit the car script for now. Yeah, we will need to specify the target game object here. So let's add a new field, yeah, public transform target in the car. I will put it over here, yeah, but the order of your field actually doesn't matter here. Public transform target. And then the next step is let's change our update part of our script. Before our update is something like this: transform the position equals to new factor 2. Yeah, we move the position x by speed. Yeah, but now we will need to actually calculate the correct velocity. Okay, so add a new float named step. Yeah, this is to tell Unity how much should a game object move per frame. Yeah, the steps formula is move speed times time.delta time. Time.delta time specifies how much time has elapsed since the last update call. So for example, if our update call has been called, let's say our game runs in 60 frames per second, 60 FPS. That means the time.delta time will be in 1/60th, 1/60 second. But of course, update is volatile. Update is subject to the frame rate, so time.delta time may not always be 1/60. It depends on your current frame rate. So for example, if our current frame rate is 30 frames per second, then time.delta time is actually 1/30th. We will multiply this move speed, which is in the user input here, or we have the float speed here. We will multiply it by time.delta time in order for our game object to be moved for every frame. So here step actually has it in unit. We don't have the metric unit here. Usually we will assume that 1 unit in Unity is actually 1 meter. For now, let's say the measurement in Unity is measured in unit. So move speed is in unit per second. To make it unit per frame, we will multiply it by time.delta time. This is to ensure that our car will move for the specified speed in unit per second. That's why we need to multiply it by time have been elapsed since the last frame. And then we will use the move towards function to move the car from its current position to the target's position, moving it for the length of step. Okay, let's do this. Prepare a float step equals to speed times time.delta time. And then let's delete this. We will change it to vector2 dot move towards. As you can see here, we have the vector2 current. The current position is stored in the transform.position field. Okay, so specify that transform.position, and then we need to specify the target. We have the target's position in target.position, and then for the last one, we specify step, as how far we want to move our car, which we have already calculated in the step variable. Okay, and then create a new TMP input field and TMP button for speed input and start button. Oh, we have already specified this. So I think we're all good. Just save your script. And then let's try in Unity, Okay, so don't immediately start your game because you will get this error, unassigned reference exception. The variable target of car has not been assigned. If you get exception like this, unassigned reference exception to be precise, just check your car. You have empty variable here, which is in this case is target. So stop testing your game. We will need to specify this target first. Let's say, okay, why my target is moved into this position? I will reset it to 0 and 0. No wonder my target does not appear in the game panel. Because the position is way too far. Okay, I will select my car game object, and then I will drag this target game object to the target field of my car script. Yeah, only by then I will solve this unassigned reference exception. Okay, I will leave the target position to its initial position for now. Yeah, I will change my move speed into 1. Yeah, in this case it's 1 unit per second. If I click change speed, then my car will move to the target. Okay, if I move my destination X somewhere else, let's say -8, and the destination Y, let's say, is -4, for example. Yeah, then my car will immediately move to the target. Yeah, if you want, you can actually move your car by pre-calculating the velocity of your car. But in this case, we use unity function here. Yeah, there is a move towards. Move towards will ensure that your game object will not overshoot the target. I will move my target, yeah, into somewhere else, somewhere empty here. Maybe it's destination 6 and destination Y 4 maybe. Not 44, just 4. I will increase the speed. Yeah, your car will not overshoot the target. Yeah, your car will immediately stop at the target's position. Okay, the remaining problem we have here. If I move my destination X somewhere else and I click set destination, yeah, you will see that my car does not face the correct direction. Yeah, it will always face right. Yeah, let's correct this behavior. Yeah, so our car moved, but it feels weird because it doesn't face the target. Yeah, we will make the car always face the target, and we will stop it when it reaches the target. How to do that? We will update the car script and edit the update path into something like this. Yeah, first we calculate the direction of our car. Yeah, actually this is the velocity factor. Yeah, because we subtract the transform position from the target position. Yeah, this creates the velocity. Yeah, but here we name it target direction. Yeah, it's actually the same. So in the update, let's calculate the direction our car needs to face. Yeah, by calculating the velocity. The direction in the velocity factor will be used to rotate the car. Okay, so I will create a vector tree target direction or simply velocity here. Velocity equals to target dot position minus transform dot position. Yeah, and then we will calculate the correct Euler angle. Yeah, by performing arctan. Yeah, atan 2 here. Yeah, atan is if you remember your trigonometry from your mathematics class in the high school or in the middle high school, yeah, then you will remember that the tangent of any angle, yeah, is y over x. Yeah, so if you need to calculate the angle, then you calculate the arcus tangent of y and x. Yeah, the tan2 function of the mathf class, yeah, will result in angle, but it is measured in radian. Yeah, so we must multiply it by mathf dot radian to degree. Yeah, to be able to convert the angle into degree. Okay, so okay, here, why is it ambiguous? Let me check here. Factor 3 is not ambiguous. Ambiguous actually. Okay, I will just ignore this error for now. Let's continue. Float angle equals to math f dot a10 to velocity dot x velocity dot y multiplied by math f dot rad 2 degree. Yeah, and then if the target direction magnitude is 0, then we will stop our car from moving, yeah, by specifying the move speed equals to 0. But if the magnitude of this velocity is not 0 already, then we will rotate the car, yeah, by using something like this. Transform dot rotation equals to quaternion dot Euler. We will specify the Euler rotation, which is the angle in the z-axis. Yeah, we will convert it into quaternion. Yeah, quaternion is used to calculate a rotation for any game object. It is quite mathematic for the quaternion part, so you don't really need to understand the mathematics behind quaternion. Yeah, but remember that you can convert any Euler angle by using the quaternion dot Euler function. Yeah, so here the explanation is target direction is the result of subtracting the target vector, yeah, which is its position with the car's vector or the car's position. And then you can get the angle which the car needs to face by using the math function a10 to, yeah, Arcas-Tangen in the two-dimensional space, yeah, which returns the angle in radian. Remember, the tangent of any angle is y over x, and then you convert it to degrees by using the math f dot rad to deg, yeah, radian to degree. Okay, let's type this part if the velocity dot magnitude equals to 0. If velocity dot magnitude, please wait for a second while I resolve this factor 3. Yeah. Why is it ambiguous? Okay, somehow in my car.cs, yeah, my Visual Studio has specified the using factor 2 equals to Unity engine dot factor 2. Okay, this is actually weird. Yeah, and somehow I have the using system dot numerics here. Yeah, I will remove these two usings. I hope in your Visual Studio or your car script you don't have these two usings. Yeah, I will remove it from here. Yeah, okay. Now my factor 3 is the Unity engine struct, yeah, and not the some other factor 3 struct. Okay, so I can continue here, yeah. Velocity dot magnitude is 0. Then I will stop my car by giving the speed equals to 0. But if not, then I will rotate my transform here. Transform dot rotation equals to quaternion dot Euler. Yeah, let's give it a factor 3 Euler, or you can also use the second overload here. Yeah, just specify x, y, and z. Yeah, so instead of creating a new factor 3, yeah, you can just specify the x equals to 0, y also equals to 0, and z equals to angle. Okay, as we just reviewed, the magnitude is the length of a vector. When it is 0, it means that the car has reached the target. Yeah, so when our car reaches the target, stop the car. Yeah, but just keep on rotating the car to face the target as long as it hasn't reached the target yet. Yeah, that's why we have the else part here. Okay, let's save the car script and then let's try it in the Unity editor. Yeah, I will save my project just in case. Okay, let's see here. Yeah, my car immediately rotated in a very weird position. Yeah. Okay, but I will change my destination X and Y first. And then I will try to give it some speed and click change speed. Yeah, my car does not rotate to the correct position. Yeah, let's see. Yeah, make sure that the target's initial rotation is 0. Yeah, and then check if the script is correct also. Okay, let's see. Oops, sorry. Factor 3 position equals to target position minus the transform position. And then float angle is mathf.a102, velocity y and x. Yeah, this is my mistake. I switched the arguments for the mathf.a102. It should be y and x. Yeah, not x and y. Yeah, if you remember your trigonometric class, yeah, x over y is a cotangent of any angle, yeah. But tangent is y over x. Yeah, that's why my car rotates to the wrong position. Okay, let's give it a try again. Yeah, immediately your car will face towards the target. If I change my destination position, the target position into something like 5 and then y also equal to 5. Yeah, over there, yeah, a little bit outside the game. Yeah, I will lower the destination y instead. And let's move the car. For example, I will give it the speed of 5. Yeah, everything is fine now. Yeah, although if you take a look here, the target is over the car. Yeah, that's fine. Or if you want, you can move your target to below your car. Yeah, into somewhere like this. Or actually, let's leave it as it is. Yeah, because if we move our z for the target into something bigger than 0, I think it's okay for now, but let's try to move the destination x and y. For example, let's give it the destination x minus 2 and the destination y, let's say also minus 2. Set destination. I will click the change speed so that my car moves. Yeah, actually the target's position is forced for its z equals to 0. Yeah, because I think in the change speed button, oh sorry, in the set destination, yeah, we give the transform position is a new factor x and y. Yeah, this will force the z value of the target's position to be always 0. Yeah, I think that's fine. Yeah, so basically our Unity project is complete. Yeah, congratulations. You have already simulated the KLP in both axes, yeah, X and Y in Unity. Okay, if you have any questions, don't be hesitant to contact me. Yeah, discuss it in the Hangouts group chat. Okay. For the last part, Yeah, please do this as your homework. Yeah, create a new scene consisting of 4 bullets. Yeah, please use the bullet.png asset on the classroom, and then put it in any position you wish. Yeah, in predetermined positions. When you left click, all bullets will move towards the click locations. Yeah, so if you take a look at the animation here, yeah, if you left click, then all your bullets will move to the clicked position. Yeah, you are free to specify the bullet speed. Yeah, no need for user input. Yeah, this animation is created using the bullet speed is 1 unit per second. Yeah, although if you take a look over here, yeah, maybe the bullet sometimes move faster. Yeah, but actually they will reach the target in exactly 1 second. Yeah, so the speed is not really 1 unit per second. Yeah, but the time needed for all of the bullets to reach the target position is exactly 1 second. Yeah, you don't really need to specify your animation that way. Yeah, it's up to you to specify the speed of all of the bullets. Yeah, as long as their speed is a constant value. Yeah, please make sure that your bullets have the constant velocity. I have provided some hints for you. To detect left click, please use the input.getMouse button down, yeah, and give it the index of 0. And then check its value. If it is true, then the left mouse button is clicked. Yeah, 0 here denotes the first mouse button. Usually it is the left mouse button. And then you can convert the mouse position into workspace. Yeah, in Unity, the mouse is in the screen position, yeah, which is usually measured in a normalized value. Yeah, x equals to 0 is here, x equals to 1 is over here. Yeah, so we must convert the screen position into the world position. We can use the camera.main.screen to world point function, and then specify the input.mouse position as the screen position to convert into the world's point. Yeah, this function returns the mouse position in world space in factor 3. Yeah, and then please set the z to 0. Yeah, otherwise sometimes your bullet will disappear. Remember to calculate the velocity. You have the velocity as a vector. Yeah. How to calculate the velocity? If you have the mouse position and bullet's current position, yeah, please think yourself. Yeah. If your bullets move too fast, just multiply your speed by time dot delta time. Yeah, this is your homework. Yeah, please submit it by the specified deadline in the classroom. Okay. To submit your work, yeah, just zip your whole project. Yeah. So for example, if my project is Hello Unity, then you can just create the zip. Yeah, please do a zip. I don't have any other means to open RAR or yeah, actually I have 7 zip here, but I prefer just zip. Yeah, because by creating a zip archive, I don't really need to open my 7 zip. Yeah, I can just open it in the file explorer. Okay, I think that's all for today. If you have any questions, yeah, please ask it in the Hangouts group chat. Yeah. That's all for today. I will see you again next week.